Okay, so welcome to my video on standard deviation. And standard deviation is just a fancy way of saying how far apart or how close together all of the numbers in a data set are. So let's take a look at this data set in black. We have 28, 29, 30, 31, 32. If we took the average or the mean of this data set and we added all of these numbers together and then we divided by 5, we would get an average of 30. And most of you probably could do that just by looking at it. And if we took a look at the data set in blue on the right, we have 10, 20, 30, 40, 50. If we took the average or the mean of this data set and we added all these numbers together, divided by 5, we also have a mean of 30. So if we just looked at the mean of both of these data sets, we would think that they're exactly the same because they both have an average of 30. But clearly, just by looking at them, we know that this isn't true. The numbers in the black are much closer together to the mean than the numbers in blue. In black, the smallest number is 28, and the largest number is 32. That is very close to our average of 30. Where our data set in blue, our smallest number is 10, and our largest number is 50. That's much farther away than our average of 30. So since the data set in blue, the numbers are much farther apart, they have a larger standard deviation than the data set in black. So that's my brief introduction, and let's just get started right away with an example. Okay, so let's pick some easy numbers. Let's say we have the numbers 1, 2, 3, 4, and 5. So the first thing I like to do before I find the standard deviation is find the average or the mean of the data set. So that's what I'm going to do right now. Now, the average or the mean I always write with a x with a bar over the x, and that is equal to all the numbers added together, 1 plus 2 plus 3 plus 4 plus 5, and then you got to divide by the total amount of numbers. We have five numbers in the data set, so we have to divide by 5. And that is equal to 3. And the next thing I like to do after I find the average is make a table. And in the left column of the table, I like to put my values of x. And on the right hand side of the table, I like to put the value of x minus our average, x bar, and then we like to square it. So on the left-hand side, our values of x are just going to be all of our values of the data points. So we have a data point 1, 2, 3, 4, and 5. And in the right-hand side of the table, in this column, we just put x minus x bar. So in the first row, we have a x of 1. So our x value is equal to 1 minus x bar, which is our average. So 1 minus 3 squared. In our second row, we have an x value of 2. So 2 minus x bar, our average, 3. And then we have to square it. In our third row, we have an x value of 3, subtracted by our average of 3. And then we need to square it. In our fourth row, we have an x value of 4. We have to subtract it from our average 3. Then we need to square it. And then in our fifth row, we have an x value of 5. Subtracted by x bar, which is 3, and then we need to square it. And if we simplify all of these rows, in our first row we have 1 minus 3, which is negative 2. Negative 2 squared is a positive 4. In our second row we have 2 minus 3, which is negative 1. Negative 1 squared is a positive 1. In our third row we have 3 minus 3 squared, or 3 minus 3, which is 0. 0 squared is equal to 0. In our fourth row, we have 4 minus 3, positive 1. Positive 1 squared is also positive 1. And in our fifth row, we have 5 minus 3 squared, which is positive 2. 2 squared is equal to 4. And if we add all of our values in the right-hand side of the table, we have 4 plus 1, which is 5. 5 plus 0 is 5. 5 plus 1 is 6. 6 plus 4 is equal to 10. So the summation of all the values on the right-hand side of the table is equal to 10. And I'm going to write this using mathematical notation. The summation of all the values of x minus our average of x bar, and if we square that, the summation is equal to 10. And we're going to use this value of 10 in our standard deviation formula, which brings me to my next point. What is the standard deviation formula? And that depends if we're talking about a sample or a population. If we're talking about a sample, the formula is usually written with an S for standard deviation is equal to the square root of the summation of x minus x bar squared, all divided by n minus 1. And n is just the total amount of data points. And if we're talking about a population, then the formula for standard deviation is written with the Greek letter sigma. And that it's really similar to the sample formula. It's equal to the square root. The numerator is exactly the same. It is the summation of x minus x bar squared. And this is all divided by just n instead of n minus 1. Okay, so many people get confused on which formula that they need to use. Let's take a look at our data set. Let's say these numbers 1, 2, 3, 4, 5 represent a sample from a larger population. If it's just a small sample from a large population, then we need to use the first formula. So let's plug everything in to the first formula. And our standard deviation would be the square root of the summation, which we know is equal to 10, divided by n minus 1. Our n is equal to 5 minus 1. And if I plug this into a calculator and round it to 2 decimal points, I would get a decimal of 1.58. So the standard deviation, if it was a sample, would be 1.58. So now let's assume that these 5 numbers represent an entire population, and we need to find the standard deviation. Then we'd have to use the second formula, which is the square root of the summation of x minus x bar squared, which we know is 10, all divided by n, which we know is 5. And if we plugged that into a calculator, we would get an approximate answer rounded to 2 decimal points of 1.41. So if these 5 numbers represented an entire population, then the standard deviation would be 1.41. So I hope this gave you a better idea of what standard deviation really is. In my next video, I'm going to talk about the bell curve and how we can use the standard deviation when we make a bell curve. So I really hope you're enjoying these tutorials, and I will see you in my next one.